Hello, Megan. Welcome back to the final part of our interview. So I'm just going to give you one more technical question and you tell me whenever you're ready.
All right, I'm ready.
All right. So I want you to imagine you're given a binary tree, right? So let's say this is the tree. Let's say 5, 1, 2, 5. Uh, yeah. Let's say 3, and then whichever one. 1, 0, and then one more. Let's say 7, 7, and then 8. Now, within this binary tree, you're also given an integer k. So let's just say k is equal to 2.
Mhm.
And what I want you to do is find the values in this tree that are in at least k levels, all right? So in this tree, we would have, let's say, 5 and 5. So these appear on 2 different levels. And I think that would be it for this tree. But note that 7 and 7 also appear twice.
Right.
But since they appear on the same level, they only appear on one level.
Mhm.
All right, so if 7 were, let's say, here instead,
Mhm.
then it would appear in 2 levels. So you would put that in whatever array, so 5 and 7, and then you would have to return that to me.
Right. What about
Yeah.
one, the node one?
I think 1 only appears once. Oh no, it does. It does appear twice. Yes. All right. So yeah, we would put 1 in there as well.
All right.
Yeah. So I think that's the entire question. You're given a
Mhm.
binary tree and an integer k, and I want you to find the values that occur in separate levels at least k times.
Okay.
Yeah.
Are there any constraints I should think of? Any like minimum binary tree? Could I be given an empty one?
No, there's always going to be at least one node in this tree. So
Okay.
yes.
And if k is equal to 0, then I assume we return all of the nodes.
No, k is going to be at least 1. So
At least one?
yes.
Okay. All right. So I know that I want to traverse through the tree for
Yes.
sure. And if I want to go level by level, that's the best way. I'm going to do a BFS search, which is a
Okay.
level order traversal. Right, so that will allow me to go level by level and kind of look at each node that I have. And if I'm going level by level and I visit each node one at a time, I can kind of maybe store that somewhere. And later on, I can use that, whatever storage container I have, to start recording the frequency of each node. And I would need to stop per level though. So for that, I'm thinking for the frequencies, I can use a map, an unordered map. I don't need it to be ordered. Okay, and let me create a function first. I'm just going to call it level for frequency, and I'm going to be given a tree. So something like this, and root. Okay.
And then k.
Right, k. Okay. So I will do. Okay, so I have my tree node that's passed in, and I'm starting with roots. And you said we have at least one node.
Yep.
Okay, so at least one node. So I don't need to check if root is null. So I'm just going to go straight to my data containers. And I want to do a level order traversal. And the way to do that, the best way, is to use a queue. And that will be of tree nodes. Okay. And I would just call that queue. Oops. And what I'm going to do is start with the root. And this is C++, by the way.
Okay.
Okay, so this means I want to start here. What my queue is doing is keeping track of what node I'm going to be visiting next. Okay, so I have a queue, and I also am going to record each node that I visit per level with a set. That makes the most sense. So I will do an unordered set. Okay. And that will be of type int for each node's value. They will all be integers, right?
Yes.
Okay, and I would just call that recorded. All right, and I'm not going to push anything in there yet. So I have a queue, I have an unordered set, and I also want to record the frequency of each node values. And I think I'm going to get that from my set since it's recording everything in each level. So I'm going to use also an unordered map with int key value pairs, and I'm going to call that frequency. Okay. All right, so these are my 3 data containers that I feel are the most appropriate for this. And I still want to perform my traversal. So I'm going to use while my queue is not empty. Okay. Oh. All right, so while my queue is not empty, I can do a for loop, but first I'm using my queue for visiting my nodes. So what I'm going to do is I'm going to get the size of that. Int size is equal to queue dot, I believe it's size. Okay, so I have the size of my queue, and now I can do my for loop. For int I is 0, I is less than size, and then I plus plus. Oops.
We can move this out of the way.
Thank you. Okay. So my for loop. Okay, so right now I'm gonna write this up here. My queue should have 5 in it. And I also have recorded, which doesn't have anything in it yet, and then frequency will be over here. And my queue is not empty, so I get the size of it, which is 1, and I'm going to iterate through the size, but I'm going to check the root's children, so I'm going to level, assuming we start at level 0, level 1. So I'm going to go, say, if we'll do queue.front val is not equal to null. So that means the child exists.
For the value?
Oh, for the root. Wait, let's see. Yes. For the root is currently in queue, so I'm checking if 5, actually left. So the child. Queue.front left is not equal to null, so that means 1 exists. Then I'm gonna need a little bit more space. Or I could do my next if statement over here. Okay. So if queue.front left is not equal to null, it exists, then I can push it in my queue to visit later. So I'm gonna do queue.push, and I will do queue.front left. Okay. And I'm going to do the same thing for the right child. So if 2 exists, and I will do that over here. So it will just be the same thing. So I'm just checking level 1. So that would be 0 and then 1. So if queue.front, which is still 5, right this time, so 2 is not equal to null, then I'm going to do the same thing. I'm going to store it in my queue since I'm still doing a BFS, a level order traversal. So queue.push, and I'm going to do queue.front right. Okay.
We can switch markers if that one's giving you a tough time.
Okay, thank you. All right, so I have this if statement. I'm just going to do this and then this to show that we are going here to here. And now that I have my if statements, let's see, I have 1 and 2 pushed into queue. Okay, and I also want to record 5. So I'm going to do recorded dot insert, and then I'm going to do queue dot front, and then pop it off. Okay. All right, so then 5 is popped off and it's put and recorded. Okay, so now I have 5 in there, and let's see, I want to end off over, I think, right here. Okay. Also, since I'm doing recorded, I'm going level by level. Eventually, I want to clear that since at most, I just want to store the nodes at each level. All right. So I also want to deal with my frequency. So I'm going to use recorded to put into my map. So recorded will be storing the nodes, and I'm going to use my map. So I'm going to do something like for auto node and frequency. For auto node and frequency, I'm going to do, oh, no, not frequency, recorded. So I'm pulling from recorded.
All right.
Recorded. And then I want to use frequency. And I'm going to access the node, so the key, plus plus. So it's incrementing that. So right now, frequency.
And this is if it's in the
Right,
map,
right.
Yeah.
So frequency, do it over here. Frequency now has 5 from recorded, and it has 1 in there. So 5 appears once so far in one of the levels. And I also want to clear recorded. So I'm going to do recorded dot clear so that it's clear for the next level and I'm not storing 5 still.
All right. And just one question real quick. So even when the node isn't in there, you're going to increment the value?
If the node isn't in recorded?
Not in frequency, right? Because like frequency is initially empty, but then you're accessing the value and incrementing it, but it's not in there yet, right? So you would have to probably set it to 1 first.
Well, frequency is going to be empty, but anything in recorded needs to first be put in frequency, no?
Yes. So then when are you putting it in frequency?
When I have something in recorded. So for each node in recorded, I'm going to put it in frequency, then I'm going to clear recorded, and then I'm going to go back up to my for loop. But since I'm popping queue, currently my queue has 1 and 2. So I'm going to check 1 and 2's children in level 2. Then I'm going to do the same thing, insert them into recorded, pop from the queue, and then these values will be stored, and then continue doing that. So my queue size will be consistently changing. And then anything in recorded, since I'm clearing it, anything in recorded that's new is only going to be put in frequency. So I'm not sure of the question.
No, I think so the frequency, when you access the 5, right, it's not going to be in this because the frequency is empty. So you'd have to say, if this node is in frequency first, then you set it to 1. Otherwise, then you would increment it, right?
Yeah, I see.
Yes.
Okay. So I could put that somewhere over here. Well, actually, in an unordered map, I believe what this does is it not only accesses the key, but it creates the key in C++.
Okay, sure.
So let me put this here. I can do something like this. So if it's not in there, it's going to create it either way.
Okay.
Does that answer the question?
Yes, I think
Okay.
so.
So recorded.clear. All right. So this will continue going over and over and over again. So if I have 1 and 2, I'm going to check 1's left child first, and that exists. So I'm going to have 5 in there, which is a duplicate. So that's good, unless it's in the same level. And then I'm going to have, let's see, 3, 1, and then 0.
Yes.
Okay. All right. So I have those. That takes care of this and this. Okay. And this is a little pretty quick, but right now I'm focusing on 1. And 1's children will be 5 and 3. And then I will do 2, which will be 1 and 0. Okay, so I'm going to put that in recorded. So that will be 1. Then I'm going to pop that from the queue. Okay, and then in my map, I'm going to do 1, 1. And then I'm going to keep doing that. I'm going to pop, record it, 2, 1. Pop, record it. Then this increments by 1, so it becomes 2, and so on. Okay. So far, that's how my data structures are working, except I need one more for loop, because I'm returning an int, so I kind of need a count variable. So I will do that over here.
Yeah, sure.
Okay. All right, so this is completely after everything. So I'm just going to do a quick auto for each loop. And I'm going to go in frequency. So I'm going to be going in my map. And this is assuming everything in my map is done. So all of my traversals for my tree. Okay. So I'm also going to have a count variable, if count is equal to 0. And assuming k is 2, then I will do if count is greater or equal than k, so it's at least appearing k times, and at least in k levels, then I'm going to return k. That's when I will return k. Okay. So for example, since 5 is 2 and that's greater than k, I'm going to add that to my count. So that's at least 1. But also 1 will end up being 2 as well, because it's over here. So that will also be at least equal to or greater or equal to k. So I'm also going to add that to count, and that will be at least 2. So I'd be returning 2 as the answer, which should be the output, right?
I think we were asking for a list of them, but I think in this case it'd be pretty simple. You just have a vector.
Right.
Yeah. But yeah, basically that answers the entire question.
Right.
So.
I could create a vector and then just have the nodes in there and then return that.
Yeah, it would be basically just change like a couple lines here.
And I'd change the
yes.
int as well from the beginning. Okay.
All right. Yeah. So then this output would create 5 and what was it? 1, right?
5 and 1. Yes.
All right.
So this while loop continues going until my queue is empty. So until I'm fully done with my BFS. And speaking of BFS, that will be for the time. I'll do O of n. Okay, so pretty simple. This is all focused on BFS as an algorithm, my level order traversal.
Right, and n is referring to the number of nodes, right?
Yes,
all
yes. Right. N equals number of nodes.
And in terms of space as well, what would that be?
I believe it would also be, so this is time. Same thing. Oh, but okay.
All right, so I think your solution works. You just do a level order traversal, then record the different ones at each level, and then
Right,
you
right.
just return them. Yeah, I think your solution was elegant as well. You got it in the optimal time and space. So, yeah, I don't have any more questions about it. I think I understood your entire solution, and you're able to walk me through it pretty well. So, yeah, congratulations. I think
Thank
you
you.
did a good job. Yeah, we're
Okay.
done.
So I'm done walking you through it. Okay.
Yep.
So I'm done with all of my questions.
Yeah.